really easy to show it to you. We have more than 4 million users accessing our platform. The user case in the way the users connect to our platform is quite strange for the rest of us. We have a burst of calls of the same user for about 10 minutes, 15 minutes, and they disappear from our view, and they come back maybe today, maybe tomorrow. We need a lot of resources when a user connects to our platform to have in hand, really close to the instance. And it's quite difficult to determine what we are going to need and when. So the user is part of an account. It has financial accounts, addresses, cards. We are a fintech solution, so you can imagine how many data we bring on each user, the latest activities, things that we need to have in hand just in case the front ask us for all that information. So we have at least 3 addresses for each user. There's a lot of information, and if you know, and working directly with the database is quite expensive. I mean, not only in pesos or dollars or wherever the money exchange you want to do, but also on resources, time. It's quite difficult to manage this amount of users getting at the same time. So we came with a wonderful solution. We created huge virtual machines. I can show the objects in memory. We managed to start each instance in about 23 minutes. That's a great success. I hope you all like it, and that's the end of the talk. Okay, now, we thought about this at the beginning when we had about 10 users. It didn't scale quite nicely. So we have to go back and think for a while. We have the concept of temperature. The temperature of an object for us is based on the user's frequency and when we are going to need it. It's quite important for us to determine how hot is an object and when we are going to need it. So the hottest objects need to be really, really close to the instance, and actually on each instance. So how are we going to manage so many nodes and so many virtual machines running each one instance, and we can get all the information at the same time, being that we are not sure that each user will get on the same node. So we have to sparse the data through something on the environment. We have a Kubernetes environment with, I don't know how many we have in production right now. If anybody knows, I don't know, but 50 nodes, I don't know. So we have 2 cache strategies. First one is quite simple. We just keep on the old-fashioned way. We keep some data on each instance on memory. This is data that is not going to change frequently, and it's finite with countries, provinces, things that we will need eventually during any user call to our system. So we have some really few products, and you can imagine, for example, books that I have there. So they are finite, they are small, and we can keep them in memory the old-fashioned way. some of them, all of them on each instance. And I said not so static because it can change. We can have a province while the system is running, of course. And I'm going to show you how we handle that, because we handle it. We don't need to restart the instance, each instance, just because we are in the province. And the nice part is incremental cache. What we do, and I'll show you in a minute, it's based on the temperature of the object, and it's going to be either all on the instance, and we have a centralized repository of cache, I will show you in a minute, where we keep cache objects for all environments. There are some questions that I managed to add at the end of some slides, in case we come to the end and you don't know what to ask. Just you can copy and paste or remember and say those questions that I have on the last part of on the bottom of the slides. The static cache, I mentioned it, it's quite easy. We maintain the cache according to the operation. That's quite easy. If it's a delete, we validate it. If it's an update, we update it. That's not, there's nothing new in there. But that cache, that object will be cached on another instance. So keep that in mind. It's quite easy to just say, okay, I validate this object that I got from the database, and I get it again because it has changed. But, and this is important, it can be the same object on another image. And we'll talk about that in a second. The incremental cache is exactly, practically the same. We, on the insert, this is important, we keep them on the environment cache, we call it level 2 cache, on the instance cache, and persistence. Of course, we use PostgreSQL as the database. On the delete, we validate both caches and delete it from persistence. That's nothing strange, and we are on the update exactly the same thing, but it could be on another instance. So we have a message broker which shows RabbitMQ. We have a farm, it's a proprietary cluster above it, and we use it to send messages between instances. I'll show you the numbers at the end, it's pretty impressive how many messages it could handle. So each machine, each virtual machine that receives an update does something on the objects that it has in memory. And let me show you what we do. On the insert, we insert on the cache. When we receive a message, each node will receive a message saying, I modify this object with that object ID. And so we keep the second level cache on main cache. You could ask me, why don't we use rates, for example? I don't have that question right here, so I'll answer just in case you don't remember to ask me about it. And we use main cache because it's a key value, and we just store the key, that is our object ID, and a serialized object on the value on main cache. And we needed as much throughput as we can get. Redis is more complex, it gives you more options, but we just need speed. So we decided to go that way. On the incremental cache, this slide is a little more complex, but let me explain it to you quite easy. On an insert operation, we insert a whole cache, nothing changes, the other instances will find it, and will select it or look for it, and they get it. But on delete, the instance that generated that delete or update, what it does is invalidate the objects and sends a message to the parent. The other instances invalidate the object and convert it to a proxy. So the next time they are going to notice that it's a proxy and we get it from the person. It's simple, but it took us a lot of time to implement it and make it work on a timely fashion, because it's quite hard to get so many transactions and a lot of things can happen. If you don't know what a two-phase commit problem is, I'll explain it to you and you can ask me that question later. Two-phase commit is when you need to write to two places at the same time. What happens if we try to write to the database and write to the second level cache, and we fail to write to the database? You have to roll back the whole operation. It's quite difficult. So if you ask me that question, I'll answer later how we solve it. We have a time to live on each object, and we have a vision strategy that we use to keep the objects that are hotter, as I told you, the temperature. We keep that object in memory, and the objects that are getting cooler are evicted from the cache. It's quite simple for us. It took us a lot of time to determine the times of the time to live. This was a lot of usage of statistics and trying to get the times right for the whole system. Right now, we have, this is a snapshot of our, well, we use Grafana to monitor our platform. This is a day in our labs. We have about 17 million, this is from one of our labs, the biggest one, let me say. So, but we have about 17 million happy balls during that day. Some of these balls can modify up to 10 objects, the balance of the accounts. So we know we manage money. We know it's important to not lose a single transaction and have a lot of all we do. So in this time we also lost the transaction. So we have a read-only database and a read-write, and we manage all our transactions. This is on the smalltalk side also. We manage where we do the different operations that we need to do. If we need to go to read-write or we need to go to read, and how we keep those databases in sync. The replica is really important that works smoothly. And on these particular days, let me show you how many, let me zoom here. we had 48 million messages moving through the environment, from one node to the message broker, and the message went through all the rest of the instances that were subscribed to that kind of message. So you can imagine that every millisecond is important for us. We are really proud of what we did well, and we can tell with proudly that all of this is working on smalltaks, so we are really happy. For us, it's a great experience, and we thank you all for that. Also, this time I'm done.
Yes.
I have to prepare talking too fast, so we have plenty of time. We can talk. So any questions will be greatly appreciated.
Thank you for the talk. One question when you talk about putting the object on the memcache, you say you put the key and the ID and then the serialized version of it. So just for me to get into the details, do you know which serializer you use? You use the object swapper from us?
What is the question? I'm sorry.
Which is the serializer that you use for
Stamp.
the
Stamp. Stamp is
stop?
Yes.
Okay. So that's text.
Yes.
Text-based.
Yes.
Okay.
Yes. It's memcache. It's
JSON.
It's a string. Yes.
Okay. Thank you.
For the deserialization, we had to work hard. I told you that. I'm sorry, since nobody is asking and we have 10 more minutes, let me complete the answer. It was really tough because if you are going to ask me how we can solve the two-phase commit problem, where we need to store in the database and store in the level 2 cache, is we delegate asynchronously to the database to store on Redis. I'm sorry, memcache. We had this discussion before. And we Postgre natively doesn't know how to deserialize and that object. So we have to manage to make it do that. Yes.
Just speaking about that serialization, how big or complex are the options that you serialize using Stone? That's the first part. And the second part is, have you tested or tried just compressing that? Because
We made some, well, how large, it depends enormously on the object, but what we do is, I think we have a limit of 1K when we don't cache that object. I need to check the code, but I think it is 1K.
what? Sorry.
1K. And the size of the object varies a lot. I mean, a province is a gold province, but some other objects like addresses are a little bigger. So it depends a lot. Most of the objects are small. We tend to keep the object as small as possible, but the transactions are becoming more big than we want. We are working on that. There were the questions for.
No, but the second part was if you
try to
compressing them using one of the browsers.
We prefer to spend. Yes, we did. It takes more time than we want to spend. We prefer to pay more for memory. It's something that we contemplated, but no. We need to be, for example, we did strange things that we managed the eviction. How do we know that the cash is up to date, for example? It's quite difficult. You can't really know if you are using a cache object that is the object that is stored on the database. We did everything we can to be sure that that object is. Imagine that a node didn't receive an update and it has the previous version of the object in memory. That could be quite complicated, and we made a lot of effort to be sure that that works. And it's impossible to verify that the object is the one that should be there on a platform base. It's too expensive to confirm that object. So on our eviction strategy, that is running concurrently with the instance, with the platform, we do that. That the object, that the eviction really happened, that that the object is not there anymore, that the object is the one that should be there. We store for each object an optimistic login on memcache for the latest version of the object. We do a lot of stuff to make sure, but remember, we have little time to do that. So
yeah, I was going to ask, how often do you do the eviction?
The eviction is running all the time. I mean, the eviction system is working all the time. But right now, we are doing we tend to keep I think it's 20 minutes, the information on the level 1 cache on the instance. And we try to keep up to 2 days. It sounds like a lot, but we can do it, so we are doing it. Between 1 day and 2 days, the level 2 cache.
When you were talking about serializing the object, and why are you doing that? Why are you storing on the cache the object as you get it from the image? Is that a strategic decision, just a simplicity one, or?
We need really the fastest throughput that we can get. Memcache does that, and it just saves keys and values, and the values string. So we have no other way to store an object in so little time in any other place than in memcache serialized.
Okay, but that's you don't need another format for that object.
We can save it on any other format on memcache, and it's the fastest one. So I understand why do you serialize it, because it's cheaper serializing than storing in memcache than any other thing that we tested. So we decided we need to serialize it and save it there, and it's cheaper than any other thing. So I understand the question. I mean, why don't you just dump it anywhere? Because we don't have anywhere. We don't have another thing that is faster than that. Okay. Thanks a lot.
Acércate, acércate al micrófono. Acércate.
Okay. Hello everybody, my name is Gabriel. It's long in the slides, but it should be. I'm glad to be here this year in this nice city, in this public university. Um, uh, Having a nice time meeting many friends in the community, so I'm very happy to be here. And today I'm going to show some stuff we have been working on. I work for Labware and for Quorum, so this is something that we have been doing with the Quorum team. Basically, if you know me, you know that we used to do this model, we still do it, we maintain it, but we are also doing new things. So I want to show you what are the ideas behind that and what we plan to do in the future, show you some code. First question, I wanted the audience to participate in some way. You are going to program, but I didn't have time to make that demo. So I'm just going to ask to raise your hands if you brought the computer with you today. Okay, that's many, but I think there's more people here that brought the computer. Or not, right? I don't know. I have two kids, one here, one here. So, if you think about desktop computers, they were just, from other case point of view, they were just an internet item. So, they are not really the thing we want to be programming in the future. They are just for programming now or in the past, and we want to do different things. So there are many kinds of computers today that we would like to program. This one, it's very hard to do Smalltalk here, right? I think very few people do that. So this is one of the things we want to have. There are also web browsers. We have some attempts. There are working versions of Smalltalk that run on the browser. They are not the most popular one, but there are some attempts. We have all kinds of IoT devices. For example, we could have something like a multi-delivery robot, why not? And it would be nice if we could program it in Smalltalk, right? So everything is programmable these days. And we want to make a Smalltalk for in the team and myself, I want to make a Smalltalk that can run everywhere. But everywhere is any computer. No matter what the size and shape, whatever. It should run everywhere with the same code, or with as much code share as possible. So I'm going to introduce 3 examples of things that people do today that might be a little bit different to use in our current implementations of smalltaks, right? We can do a web server, right? But let's say somebody wants to use this library, which is written in C++, and write a web server. So what they do, they write some code. The code says, okay, create this server thing, and we are going to pass you some function to basically show content to somebody else, and then we say server listen, right? And there we find our first problem, because this listen thing is a blocking code. So if we use that from smalltalk, we'll block the whole smalltalk, right? So all the ID, everything. If we want to use something like this, we have to do something special with our smalltalk, because we lose all our tools. If we do a GTK application, it follows the same pattern. We create some kind of application, we add some widgets to it, and then we say, the application run, and that's a blocking code. So again, we're in the same situation. If we want to do some kind of Node.js application that serves some content, it's similar to the first case, running on different platforms, but again, you just create a server, you set it to reply to things in some way, and then when you say to it listen, you lose all contact with everything. So the thing is that we are not in control anymore, right? And with the tools we have, we basically have something that is called an event loop that is running on the background and that is pre-tied to our image. And well, sometimes it would be nice to be able to configure that in a different way, or have our smalltalk run in a different way that is not so tied to the UI. So we are not in control anymore, and or we find situations where we are not in control anymore, we cannot be in control anymore, and we need to adapt our systems to that. So the idea with egg is to find a way to solve that. Just one way. So what's egg? Well, egg is a smalltalk that is Git licensed. It's available already on the web. It's fully free. You can download it. It's very, very, very at the early stages. So if you try it, you will find that it doesn't work yet. So you have to solve a lot of problems. But we are very happy making it evolve. Some of the core ideas of this smalltalk are that we want to have a minimal system where code is divided in modules and there are no global variables or almost no global variables, and where the modules depend on other modules and the code is loaded as modules need. And one of the nice things is that you usually don't need to save the image, because basically you construct the image by specifying which modules you need, and those modules will specify which other modules you need, and in the end you get like a graph of dependencies, and when you want to load the code, you just load these snapshots, which are like snapshots of the image, but instead of being of the image, they are just snapshots of modules, right? So they are tiny things that you can load without needing to load the file or without needing to load anything. You just load your module, and if that needs another thing, it will load it before and follow all the chain until you have it. Then one of the other core ideas is again that you have your code base that is written in smalltalk, and you will load whatever you need, and you should be able to share as much code as you want. I will show more of that. And one other thing is that we implemented many VMs to be able to run this same smalltalk code in many different platforms. So I'm going to talk about 4 different VMs today. It's not a VM talk, so don't despair. Um, and one of the last ideas is to be able to let people that is not small talker to use this as a way of entry to small talk. Like we might have some not small talkish apps like command line applications, web servers, things that are usually not frequently done in small talk, but to still have the development environment that we are used to in small talk. So, what's the plan? What we want to have, right? Because what I'm going to talk about here is something that is more or less in the way of working, but not really working yet. So the idea is that you are going to have a project manager that is going to let you create applications, right? So you are going to say FPM EO application, and it will create an application which is basically some module, right? That is there, and has nothing. So then you will have to say which things you need to be able to run this application, but in principle you can just say FPM start, and it will run your module, and it will run the main method of your module, and that's all it has to do. If your module does something, it imports something, it will load it, and it will run, and it will finish. And what happens if you wrote some code and it didn't work? Well, you can do something like npm --dev, and then that will start the module at the development mode, and in that case it might load your native IDE, or in our case, one thing that we are going to use a lot is something that is called website that we probably saw in previous class. Well, that's the plan. Let's talk a little bit about the available VMs. The first VM that we did was like a virtual machine, because I like doing virtual machines, but that wasn't enough. So we implemented a virtual machine for A on top of Firewall. The thing with that is that it already knows how to read small code and a lot of things. You can buy things easily. So it was great for creating the system. And then we said, okay, we want to run this system in native platforms and in JavaScript. So we need two more VMs. One was a JavaScript VM that basically is JavaScript code that interprets bytecodes, edits bytecodes, and runs on any web browser. We use it mostly from Node.js, but it should be easily run on web browsers too. So there shouldn't be much differences, but we usually use Node.js because it has less security measures than the browser, so some things are more easy to try in Node.js. We did also a C++ interpreter because, well, basically if you have a platform where you have a C++ compiler, then you can run that interpreter, and basically any hardware has C++ compilers. So basically that allows us to run everywhere. And we also did something that was called the UNMdP. It's a bit simpler VM where all VM components are coded in Smalltalk, even the compiler and everything. So that's available too. It's still not working yet, but we plan to make that work soon. So these are all our VMs. So the idea is that you can run any of the VMs, but you will still run the same code, except for the platform code, because maybe if you're running Node.js, you want to use, I don't know, React. So that's something that you will only load when you run using React. If you want to use the native VM, you can maybe load, I don't know, some GUI library or things like that. So now I'm going to basically do a small demo. So put your helmets because it's going to be very dangerous. So let's start. Okay, so what I will do is just give a glimpse of what this system has and where. Is it good? Okay, so what do we have here? This is basically, I just cloned the repo for this demo, and this is what I got, right? We have this modules folder and this runtime folder. Let's go first to the modules. Modules are small code. The code is stored in total format, and you start the system by having just a kernel, and this kernel has the typical things that any model has, like collections, numbers, errors, that kind of things, right? It also has modules, so everything is stored in modules, and if you don't have a module loaded, you can load it. So if we go to collection, we will find the code of collection in total format, nothing very fancy. Then we have different modules, right? For example, we have the compiler, which is in another module. Each module has a class. It's optional, but most have a class that implements a subclass of module. And in that class, you can say what you import. So in M, we have namespaces. So if you want to use something that is in another module, you have to import it. So if you want to use byte array, well, that's already loaded, but it's not available in your namespace. So you have to tell the system that you're going to use this. And after you do that, you can just use it. We have different things. We have, for example, support for FFI. This is a kind of module that only works for native platforms. You have, I don't know, edit parser, Stone, so you can read code. And the idea is that when you want to run something, you need a small, you need some module to start, which is your module, and you also need the kernel, right? So what the system does is to load the kernel and then load dependencies of your module until it's done, and then your module and executes main. So I'm going to show an example of that. So here we have examples, and we have hello world. So the hello world module is quite simple. It just imports transcript and says transcript show hello world. And actually this, probably if I wanted to do the demo with this, it won't work because this is just example code and we don't have transcript in it yet. Basically because we haven't needed it. I'm going to show why. But basically what you do is to tell the VM to execute this module and it will be executed in the argument. So what I'm going to show example something a little bit more complex, which is the same C++ example with the web server that I showed before, but this time it's done in Smalltalk using the C++ server. So this HTTP server example module uses the C++ HTTP server that we saw before. It also needs FFI because you need to call C code. And what it does is to create this HTTP server, give it some API that will serve, give it some base URI, and just one place to call. And then you start it. And when you start, it's again what we saw before. So let's see what this CVP HTTP server is. What we have here are two things. One of them is the small code with a wrapper to the library of the HTTP server. So if we go here, we'll find that the library name is HTTP server and that has some functions that we are wrapping. We have the start, which was the one that was blocking. And as that was C++ code and it's not easy to call C++ code directly, we have some C wrapper here that basically takes the C++ objects and wraps them into C codes and C functions that you can really call. So if you compile this, you get basically some HTTP server library, and you can load this module and you can call all the functions of the C++. Well, not all the ones you run. So let's go to the console. Okay, so here we are in the demo folder, and we have this image segment thing. Right? What do we have here? For example, here we have something that I built previously. Basically, modules that have been loaded and compiled into snapshots. This is binary information that has all the objects that this module contains. This module contains. And they are very small, as you can see. The modules are only a few kilobytes each. They are very small. So what the system does is to just load whatever it is. And what I'm going to show is what happens when you try to run this HTTP server. So the command line option to do that is to just call head, which was compiled in some folder called runtime CVP, and tell it to run examples HTTP server. And what it's doing is basically loading all the modules. It's not loading. And now we can go to the browser and say load, and we have an HTTP server that is just running, and it's okay, right? So it is that we just loaded the minimal amount of things that we needed to run the thing. Okay. I could show a lot of things, so I'm going to.
Can you show how much it takes memory for that process?
Yeah, I could. So I'm not sure how, but
Yeah.
Probably in the browser.
Sorry?
On the browser, probably.
No, but just on the browser, I could show you how much the browser is.
Yeah.
We want you to know, I think, how much this process of the server is.
Oh, you stop. Open another tab. Open top.
Sorry?
Open top.
Okay. Yeah, I see what you mean. I don't know how to search for it because it's using very
So, but
small.
if you launch it with -7 net, it will sort itself according to learning be much more stable. Whereas
So what should the command be?
top -7 net.
Yeah, you can press F5.
On
O space net.
and then ref or something.
H top. Press F5.
Okay, let's do it some other way.
I'm sorry. I'm sorry.
So we have some information, right? This page is running without the garbage collector or anything. So what we can see is that it used 25 megabytes of memory. Probably you could run it with a smaller chip. I use a medium-sized chip because it doesn't have UGC, so it would crash if it uses all the memory. But you can make this very small if you want. And this is also some memory that is used by the debug information in the C++ interpreter because it's compiled as debug and not released. So it will be much smaller.
It's only resident.
Well, okay, yeah. Well, there are different ways to measure, yeah. So we are not sure how much of how much memory is used, right? So let's continue a little bit because we have very little time. What I'm going to show now is running some similar code, but that works in Node.js. So in this case, where we are here is runtime-js /js. So what we have here is basically that we are importing the virtual machine written in JavaScript. This is x.js. We are also importing the website library. We are loading the kernel file into the virtual machine and then a couple of modules. You see that it says for each module, this variable, load the module, and then it starts a website server that will serve the contents of the egg runtime. So let's run that. And let's go to the so we are going to connect to it. It's running a website in this address. We are just connected, right? So what we are seeing here is that we are browsing an image of egg that doesn't have any ID loaded, and it's just loading some things, the things we wanted actually, like, I don't know, email modules, and we are connected to it and we can do stuff with it. Let's say, let's open that browser, let's open some tasks. Let's say this transcript thing that is useless yet, and just you can basically, as Guillermo showed, if you serve the API, you can do anything. So, for example, so we can do here, for example, transcript, view, show it, and it's just running, right? It's running on a virtual image inside the JavaScript engine. And the JavaScript code interprets the smalltalk bytecodes and runs them. So that's basically it. I have no more time for demo, sorry. I think I bored you enough. So let's continue. Just final things, final thoughts. This is something that works as a service, right? You just know your smalltalk and you tell it to do something, and then you go away. So it's not a typical smalltalk that tries to do everything. It just provides you services. You could use it for building a traditional smalltalk. It's not a problem to do that, but you don't have to. It allows different mechanisms to control things, like what we saw with the giving up control and giving it to some arbitrary library. And one other thing is that you only pay for what you use. You can load very small amount of things, and so you're going to just use very little memory. On the other side, well, basically, you only get what you pay for. So you might have to do more to have more things, right? But that's basically the idea of it. I'm not sure. Well, we have a lot of things to do. AGC is one of the things, and the other is that, as I showed you, that everything has namespaces. If you try to access something that is not in the namespace, that will raise an error. It's not does not understand. It's called does not know. So the object that is trying to send this message to an object that is not known, then it sends does not know in a similar way that does not understand. So we have to work on more platforms, we want to work on mobile, and we have to improve performance. There's a lot of space there, more modules, and that's insane.
Good job. My question is, when you showed the first example with the web server, and you started with egg, the example, in the console, it looked like it would load each module. Is the right move? And you even said that there's no concept of image by this for now.
Yeah, the idea is that you can create the image dynamically as it was created there. You told it to load the HTTP server, and that needed FFI, FFI Linux, FFI whatever. So it loaded each snapshot of each module that is generated or should be generated in the future automatically as a cache.
Yeah, exactly.
So you don't need to load the compiler if all your modules have already compiled the snapshot.
Okay, my view was maybe eventually in the future, doing what the run startup may be too expensive for certain usage, right? Or,
yeah, of course. You could at some point say, I want to save it.
Exactly, or maybe say this. No,
yeah.
Exactly.
Yeah, it's not for as I said before, you can build a traditional smalltalk with this. It's just that it allows you to do some different things.
Okay, perfect. Thank you.
Okay, thank you.
In this talk, I will present you the work on YesPlan. YesPlan is an event venue management system built inside Smalltalk, and it's been 15 years. 15 years ago that we started first nights of YesPlan in 2009. So, what is YesPlan? Well, it's a web application, a software as a service application, which is there to does everything to manage your event venue. What's an event venue? We all know this: cultural theaters, art centers, cinemas, even some museums, festivals, concert halls. These are the typical customers that use YesPlan. And what do they do with YesPlan? Well, of course, they plan all the events that are going on in the event venue. And that includes just a calendar, of course, with all the data which has associated to this event, but also about all contacts and relations, suppliers, people that have to do this event. You have to manage a customer relationship management system, resources, lighting, engineers, so people, human resources when they would have to work. And then this all, of course, all costs something. Both to the event venue, there's a price that they need to calculate, and also that they can use, of course, to invoice to customers organizing events in the event venue. So, and that, of course, includes things like features like reporting as well in there. So here is just a couple of larger cultural event venues which are on the customers using YesPlan. I think one of the largest is the Kulturhuset at Stockholm, but maybe not the most widely known. If you have the Sheffield Theatres, this is where the World Championship of Snooker is organized every year, so those people watching snooker. That's partially organized in YesPlan, I would say. There's also Flagey in Brussels, for example, from the Queen Elizabeth yearly the world famous competition of music. Or, for example, other things like Oslo Concertus and so on. So those are the typical customers which use the YesPlan application. So what will I do in this talk about YesPlan? Well, I'll give you a quick demonstration of what the system is, how it works. If I really need to demonstrate, of course, everything that is in YesPlan really needs more than 2 hours. So I'll try to just give you a brief glimpse to get an impression about what this system does. Then, maybe the longest part of the talk, of course, I will try to give an overview of the most important points of the tech stack that is behind running YesPlan. Then first, a bit of history. As I said, we started in 2009. It's a collaboration between Art Center Facultad, which is a cultural center in Ghent, and if you were at ISO in 2011, that's the cultural event venue. Which created YesPlan together with 3 people, which are software engineers or developers, amongst I am one, and that's inside. So both of us, both of these actually founded the YesPlan application, and in 2011 we became a separate company, and started actually selling the system to other cultural event venues in Belgium, the Netherlands, and then the rest of Europe, going to the US and the world, let's say. And in 2022, so 2 years ago, we got acquired by ActivityStream. So YesPlan is now part of the product suite, which is offered to cultural event venues or event venues in general by ActivityStream. Actually, we always wanted to, as a mission of YesPlan, is to enable the organization of event venues and with an application that is also nice to use, because in the beginning we went to customers and we say, we have something to help you organize events, and they said, oh, we have Excel. Which is, yeah, but take a look at this. Well, we don't need it. Take a look at it. Oh, we need this. So the part of having an enjoyable user experience for the people who need to organize these events was important. So, demo time. Of course, I'll be using my local installation here, so it's full of development test data, not real world. So I could open another one just to give you the impression of how a real planning looks like, but for demo purposes, let's do it like this. So when you log into YesPlan, the central part is the calendar interface. That's of course the overview of what kind of events are being organized in the system, and that's how everybody, the entire organization would log into. You have horizontally dates, vertically these are locations. Now the locations themselves, they can be customized, of course. This is customizable by the user. They can enter as many locations as you want. We have cultural event venues ranging from 10 locations to 500. And that will be a scalable, that's a scalability challenge. So of course you cannot open them all at once, but you can easily enter or remove or add things here. So everything is customizable here. This is just plain CSS possibilities. But in this case, for example, all the dynamicness, I could have an event which is organized on the 11th of November, but I'll just move this one to the 2nd to the 12th here. And so I could also, of course, have in-place editing, which is everything is there. So this is the overview of events. Events are like single events in a location, but you can also group them together. That's when I hover over them. So that's how they have the concept of festivals or things which belong together. Like for example, here the film festival, which is then a couple of different events in different locations and so on. I'll open the film festival. So for example, and I double click and I get diving into the details of the event, of course. Which has a lot of tabs, and these tabs are also customizable, and all the data they put on the tabs is customizable. And that's also ranges from a couple of tens customizable fields to a couple of thousands they would enter. And don't ask me, but they have lots of data they want to associate with the event. And then of course they also want this rolling out in a report. And we broke Excel in the beginning when they said, okay, we'll export everything. And in the beginning of 50 years ago, there was a limit to the amount of columns in Excel. Yeah, that didn't work. But there was so many columns. Anyway, so that's just a quick overview here of custom fields. We have all kinds of custom fields, so we enter date fields, just text field, drop downs, checkboxes, and so on. We offer those all kinds of things. Also, just auto completion within myself. This is a contact. Well, should be in there. I'm not in there. Administrator. So, of course, all of this runs C-side, the backend, so all the basic interface is C-side, and it's the things I was explaining. We started out with C-side plain rendering, but that didn't work. It didn't scale quite fast, as you can see here. We imagined first a calendar with just this amount of locations, but the first thing that event venue does is have 50 locations, and they open a calendar for an entire year. And then whenever you do any update here, they want it to be very snappy like you see here. So immediately you start, of course, implementing jQuery, jQuery Ajax updates, and having the system doing those things. Yeah, so an event is actually complete with schedules. There's no schedule here, so I'll just add one, just to give you an example of view of how this works. I think this is not a computer, but I don't know I can enter anything, so that doesn't really matter. So if you have details of the event going from one thing to the other, everything they can enter here, they can customize so other people can enter any kind of value, or they are not allowed to enter other values and so on. So everything you see here is really only just the default. I'll go through the system settings, but as I mentioned, it's impossible to give you an overview of how customizable it is. These are then the locations. These are different ways of entering the resources. So I'll book some here on the event here. Let's put 100 beers. So for the entire film festival, I reserved that. But of course, normally you would enter like a light engineer here or other elements. And then, for example, if they plan events, this is mostly 2 years in advance. They wouldn't want somebody specific on it, so they would just have an engineer and then have a placeholder. That means in their planning they can see, well, I need that many lighting engineers, I need that many receptionists for events and so on, and they can just afterwards they can actually use drag and drop to fill those in, or here in an autocompleter, I'm swapping it with somebody who has got Frank. Frank is actually an engineer in our test theater here, and then you can assign it to the student. Prices are in there, I'm not going into detail. Also tasks associated with, just some overview. what's your margin, what's your cost, how much you are charging for this event. You won't start rolling out. Yeah, have an entire logging history, very important. It would sometimes come up, oh, we have an event which was gone. So who did this? Everything is logged, of course, in the system. A quite extensive permission system because everybody in the entire theater is allowed to log in, from the CEO of the theater to the cleaning personnel. They need to log into YesPlan, and then you have a quite extensive permission system of who is allowed to do what. And then, of course, all the custom tabs, and that's where they organize the real data, which is important to them, so everything is customized. Yeah, events have a status and a profile, that's the colors you see here. And these are also customizable. I go to an option request, that looks very nice. Go to a confirm option. But I'll also say, well, the profile here right now is project. I have something called age. And these are all customizable options, of course, because every theater has its own way of working with the system. And the calendar in the event inspector could, of course, just start scrolling through my entire year. Dynamically extensible here. I have a way of searching for availability so that you can, or looking for an event or some groups. And also, there's a couple of cultural centers who have like courses being organized, so you would look for a place to organize a tango course, for example, and during every Tuesday evening, where can I do this? As examples and so on. There's also team planning. So once you have all the events are in there, they need to do the same thing for people, not just groups where they would assign the event to. And that's, for example, here. And then the events are on the right-hand side, and planning people on an event is just as simple as dropping the schedule here. And now this guy is actually planned. I'll take another person who has a contract, which then shows you something else, which is important because the YesPlan also helps them to adhere to labor rules, which are customizable per country, because people are not allowed to work for more than that many hours without breaks, or have minimum amount of time in between different schedules and so on. And these are all very important things, and YesPlan will actually help you not to overload your employees. And so it actually shows lots of conflicts in the system. Actually, you can enter everything into it. You can double book rooms and everything. We take the philosophy of it's better that they are able to enter anything, and we just have a lot of warnings and conflicts of things you need to solve to make a coherent plan. And then, of course, also the amount of time that people are working on. Doing a shift here, I think I should show that I'm working 24 hours here, for example. Yeah, and then there's just the overview of getting your resources to book on a system. You have an entire database of resources you can assign to your event, keeping track of double booking, contacts to assign, same thing, different interface. So everything I was showing before is plainly seaside with Ajax or jQuery updates. When we did the resources here, they wanted to be able to search immediately and have immediate feedback. So at that time we said, yeah, it's going to be really difficult with the client server router. So this was before there were other JavaScript frameworks. So that's actually completely vanilla JavaScript implemented, but that when you start searching, it will be completely client-side. It's a little bit changed. But then the other parts here, for example, this contacts here, this is actually a jQuery data tables run in a React.js component. So there we took more of existing approaches, and this is a completely client-side component, but it's integrated inside of our Seaside application. As the thing I mentioned on Wednesday, I just have a Seaside component in there which doesn't have any of its own rendering. It just renders the script which initializes this React component on the side. Enter and get some things. Really customizable and bonus. I'm not going to go through all those things. Just that searching and so on. And just to give you an idea of how customizable the system is, for events, you would say these are all my custom data fields, these are all the possible types, and they would enter, as I mentioned, a couple of 500 ones. All the tabs, they would pick their own tabs, given the order, giving the visibility to who can view which tab. Statuses with specific meanings, some things are an option or whatever. allowed to enter actual values or not, depending on whether you are pre-invoicing, after invoicing. Colors, limited set of colors. We didn't want to see people having yes plan with really crazy, crazy set of colors. So that's our interaction design that kind of prohibited it, because I put a tool in there. You could select any kind of color. You restrict the amount of colors here. Any interaction design. So yeah, labels, schedule descriptions, and all these things can be actually configured. So just to give you the overview here, that's the YesPlan application, and that's what these cultural centers are using to plan entirely their events. Needs to be online 24/7. Most of the uses are, of course, activities done during the day, because that's when people are mostly actively planning. But during the night, all the information needs to be available when the event is happening, so they are able to look it up. So any downtime we have is something which is very annoying. So we don't have a lot of them. I will show you, but it needs to be all the time up. That's very important. Another thing I can show, and this is where we went completely React.js, so everything here now is also embedded inside of the C-side application, but here we went completely React.js, and this is a way to create our grids, I would say, our data tables, so they can create their own reports. For example, I will create a report about events, and I can go and select some columns, and you immediately see here why this is created with a C-side application, but more as a client application running inside your browsers, because we have much more immediate feedback. So for an event, I can see all possible properties, and then I can go and dive into a certain property, add that to my definition of the columns, and then just fill in a couple of default parameters here. I'll just enter start and end date as conditions, and then I can have a list here. This is also infinite scrolling interface, and change my conditions. So we have an entire system built on top of the data model of YesPlan, so that we can easily add other conditions and other possibilities, so they can create tabular reports. We have other reports which are PDF reports and so on, which we have to design, and that this will be put to such reports. All right, that's already a long time. So yeah, here, right. So this is giving you a brief idea of what actually the application is doing. And just to give you a couple of numbers, we have a little over 480 venue customers. So these are venues, mostly in Europe. We are starting to get some in the US. One of the biggest things was adapting the YesPlan interface to US dates, and especially non-military time interface. So a couple of things there. Some shortcuts we took were in the way, but mostly just designing a way to, if you're entering times in a fast way, AM, PM, and then also because it's Europeans trying to work with it. Interesting. We have about 23,000 users. That's because we don't charge per user, so they just enter everybody, the entire system, every venue. So we are charging per venue, not per user. But most of them are 50% of them are actually active users. So we take an active user, we take a statistic that they have logged in today, every day. And so about 50% of these are active users. And during any given day, let's say at the peak time, we have about 4,000 sessions. So 4,000 simultaneously active users using the system. And at this time, we're almost at 10 million of events which have been added to the system, and in roughly about 18,000 locations, so calls. And it's not one system, it's distributed among different instances, so this is the sum of all, right? Just to brag a little bit. So this, for example, is a Grafana screenshot I took last week, where it shows you the number of sessions per day. You can clearly see when there is the Saturday and Sunday, there the system is used less intensively, because the most intensive use is people planning events, not people consulting data. So there you see, for example, every Tuesday is the most busiest day of YesPlan, has the highest peaks. You have to take a look at the green green ones, the blue ones are overheads of just people hitting the login page. So that gives you an idea, but it's the sum of all our instances, as I will tell you. We run every customer in a separate instance. Just some technical numbers. So we've been doing this for 15 years, and we're at version 31, which means we have 31 major versions which were released. The major version, which we would define as we need to have a downtime for a customer, meaning that we have to do some data migrations. And all the rest is, of course, bug fix releases. Just to, well, it might be, you might find this a lot or not, depends, but just to give an idea of the size of the system, it's about 500,000 lines of Smalltalk code, and then about 100,000 of JavaScript, CSS, and there's a couple of other things, of course. Roughly 400 C-side components and 670 data model classes. That's because we have lots of kinds of data. I wasn't able to show you everything, but this is quite an extensive data model. We have about 10,000 automated tests, which we run every night or on request. And most of those are user interface tests, so they take quite a few time. So 2.5 hours of build time over the parallelized testing. I'll show you later as well. And so these 480 customers, they translate to 480 gemstone databases run. And we have 41 servers. So over those 15 years, I would say, number went up and down for a couple of times, but I would say we average out of 5 developers. So that's just a bit of background there. So the tech stack of the S-Plan is I tried to put the most important ones on here. And first of all, let's zoom in on our use of Pharo and Gemstone, because what we are doing is developing in Pharo and deploying Gemstone. So what does that mean? I have this, of course, the demo I gave here was running in Pharo, so as a developer I can just run yes-plan with Pharo, but it's of course not in a scalable way. I don't have a database. Well, the image is my database in this case. But we just use Git, of course, to store, and using Iceberg now, more recent ones. Previously we used Monticello, of course, but now source code from Pharo goes into Git, and then we just use Metacello to load this into Gemstone. So very easy, nothing else to it actually. You just need to take into account, of course, some differences between Pharo and Gemstone. That's what you need to do. But of course, sometimes you need to do some things, or you need to do some development in Gemstone, take a look at bugs there, do some debugging. So there, at this moment, we use Jade and maybe some Gem2 still. Yes, it's still running around. That's because we historically used that to connect to Gemstone and then debug your system. And if we need to, we would from there publish it using Monticello file feed back into the Git repository. If I make some code changes, most of the time I would just make the code change in Pharo, publish it there, and then load it back into Gemstone. Much easier. What is probably the key point, and my major best experience with this approach is that when we do some deployment in Gemstone, we have the object log, and any production error is being saved into the database. So your entire debugger is immediately available in the database. And in the beginning, we had we always write bugs, but especially in the beginning, we wrote some bugs, and the early customers, of course, and they were very, very wary about the fact that we were just beginning. But the fact that when there was an error, we were actually able to repair this in a very fast time, at least for them. They said, yeah, you had errors, but you also fixed them in no time. And I think this was one of the major advantages to that immediately, having the ability to look at the bug, having all the data available, and actually even fixing it immediately, of course. If it required only small code changes, you could immediately patch the system. I think this is still one of the most important parts. When I go to the JavaScript stack, I don't have this, I use this special. Another thing is that if you were at ESOC in Barcelona, where I presented yes-plan when we first started and we didn't know whether we would have customers, we actually started out as running not with Gemstone, but using GoodsDB connected to Pharo 1 or something. But we actually quite fastly hit just the performance limits of that system. And then I just took a graph here from that presentation back then, where we loaded 100,000 objects into our seaside session, let's say, and then try to modify one object and see how long the commit took. For example, goods with a manual barrier, of course, went really fast, but Magma and outputs with an automated barrier, that took us 6 seconds, and it was impossible to use, of course. And with Gemstone, the number there is quite large. I don't exactly know what I measured there. So anyway, I took the graph especially to show you the difference, and that's when we decided, well, we need to move to Gemstone, and we'll use the performance there. So that happened in 2011. And there is, of course, a big difference. We used to have every seaside session was a database connection. For every seaside user, every session was opening a database connection to the goods DB. Because that's a different view. We relied on transactions to have conflicts between sessions being reported. When we moved to Gemstone and we did the last version of seaside, every request is a transaction. So you have to deal with this differently. I don't have time to explain that, but that's one of the major differences if we have an abstraction layer for it. So there's Greece helping you taking care, or at least what Seaside uses to abstract the differences between Faro or different platforms between Faro and Gemstone. So you use Metacello, Blast, of course. Maybe in the future we can do GD for Gemstone and JGuide to do the development instead of using J. But I always say the developments in the pros here are using Gemstone, of course, is that transparent persistency. I can let people develop in Faro and just say, yeah, don't worry about these transactions, they just will happen in Gemstone because every request made in the seaside application is actually just a transaction. So that's a pro, they don't have to think about it. Good people on the development team don't have to really think about these differences. Especially we don't have to care about object creation. We don't have to explain people who are using object-oriented database. We can just do the queries in Smalltalk, just like what we've seen with Norbert. And it's of course a live debugging of production environment. That's what I showed. I also listed the transparent persistency as a negative point. That's because at some point you have to think about that it is not transparent and there is a performance impact and there are transactions. So of course this is also a negative side of trying to hide something that is there. So I listed it as both a pro and a con to do that. Alright, I have to move faster because, alright, another part of course in the development, and I'll go really fast, but it's basically also what I was showing on my first talk. In the beginning we developed just a plain seaside application. We noticed that, okay, this is not going to scale because we have to re-render this entire interface all the time, it takes too long, so you have Ajax updates. At some point we thought, okay, all these scripts they are growing, and just put a couple of snippets there, which things are going more and more complex with jQuery scripts. So at some point we started introducing, and this is the old interface of tree view. I didn't look at the tree view, but you could also visualize these events as a tree view. First we did that with Seaside Dynamic SVG, so server-side generation of SVG, but this was of course not going to give you the interaction and the dynamicity of the user interface, so we moved towards client-side implementation, in this case using D3.js, for example. But also the embedding of React.js, and especially like the data views interface here, we started implementing for all the user interfaces requiring more dynamic updates directly in the browser. We actually moved to React.js integrated inside of the Seaside application. So I went over that a little bit quicker. Other operations, as I mentioned, every venue has its own database, one stone. This is commercially a very good argument because they will always ask you how do you ensure that the data will not leak to another customer. And I would just say, well, it's impossible to leak because it's a database. So no developer error will ever result in a data leak to another customer. I might, of course, copy the database somewhere else, that's something else, and no program error will yield a data leak issue here. Another side, of course, everything is then separated container, let's say. So what we do is we have about 12 stones per server, mostly memory bound, because you would give we give 1 gigabyte of shared page cache to every customer. So that means already like 12 gigabytes just for shared page cache. So we put 12 stones per server. there's 3 gems, which is the seaside virtual machines handling HTTP traffic. So for every stone or every venue has 3 parallel virtual machines handling the HTTP traffic, and then there's 1 gem handling like long-running tasks. You enter a query, run a report, run a data view. That takes too long to be done in the time frame of handling HTTP requests. So that's actually offloaded to a service now. All of this is automated using Ansible playbooks. So we have 480 stones. That means we have 480 stones to maintain. Of course, all of that is automated. Setting up a server, setting up a customer, removing it, upgrading it, everything is done through Ansible. We could say, well, on this server it's getting a little bit too busy. We don't have dynamic load balancing of busy customers or large customers. We would more do this on looking at, okay, maybe this server is too many large customers, and then we would move the customer to another server just with 10 minutes of downtime. And with this, actually, we avoid also to have to think about running a multi-tenant system and thinking about how to scale a multi-tenant system. You just avoid it. It's a little bit the same. It's the same argument that Norbert was making. You just do not try to solve the scaling issue here. You just have every customer. It's more or less predictable how much they will use because it's one venue, and you never need to think about suddenly peaks of millions of users inside of this system. So every customer is more or less a predictable load. So it's an instance-based cloud and not a multi-tenant cloud. Other things, of course, we do continuous integration with Jenkins in our case. So the things we're using smalltaks CI, Parasol. Parasol is the system to do some testing on your C-side application. It doesn't have to be a C-side application, but it's integrated with it. And then we do just download the images into the Power Launcher directly from the Jenkins server. Going a bit faster because I like to open up some other things here again. Yeah, and I'll just drawing made by my DevOps engineer. Just copy pasted it there. All the stones, of course, are monitored using Prometheus. So we have all the data running into it and showing into a Grafana database. This is then also reported. We also reported to HostGenie. If anything goes down, we would be alerted and so on. But for that, I was kind of thinking, just quickly open our Grafana interface here. So, for example, this is the live operations setup about all the different. Well, we just have an API exporting numbers that's ingested by Prometheus, and you just import this into Grafana, and then you have an overview about whatever. So this will be the operational dashboard. How much or where customers are with some errors on their logs. So there's a couple of errors, of course, here, or how large the databases are, how large the extent is. The number of users at this point in time should be lower now because we are fresh now, just going down, so for example. Other kinds of overviews here would have one client's installation. Which one? Take this one. And you get some numbers. So with everything here being monitored, we also have on it looking at whether the system is running, and all these things would actually report alerts to the central system and alert the people who are on call to watch. That's basically the entire deployment setup of the system. All right, I think I pretty much lost my time already. I hope some of the things you see here have raised some interest. Any questions?
Even the use dynamics you have, basically having like the peak user of Tuesday, maybe you're one of the few companies where deploying on Friday is actually safe.
Yeah, no, I prefer not to. We also like our weekends.
You deploy on your
can you share with us about how much, because I understood you were like 5 engineers working mostly
On average, yes.
and how much did you guys, if you remember, you were there, took the first, go to market the new viable version of it at the beginning, very cheap.
You mean the initial efforts to go to market?
Right.
That's the question?
Yeah. So much, because to understand the velocity at which you discovered what the actual product that people could buy.
Like that. But I think one of the success factors here is that this was, well, 3 software engineers, but especially our UX designer and the project manager were people from the cultural sector themselves. So they were actually, they told us together with us, build the system, and they have the knowledge, but they also have the contact. So I think the success of Yes Plan here was a combination of 2. I think if you go back and find the movie which was recorded at ISO in Barcelona, you would say the calendar hasn't changed much, and it hasn't. It actually looks exactly the same. So there's actually a lot of features which were added on top of that, and not really immediately visible in the calendar main interface. But the initial effort to come to a working system which users were happy to start using, which were their basic needs, it was done by 3 people, but they were working only evenings and weekends. So I would say this is 1 person over 1 year. And that's the first version presented in Barcelona at ISO. And from there on, started growing further.
Okay, there's the power point for that. So these of you and so powerful to do something that makes sense like that.
Yeah, but we also had a lot of mistakes, which, which sometimes you can still find.
That happen in anything, so don't worry. And the other question that I have is more on the SRA side or how do you deploy? Because you mentioned 41 instances, right? So with different clients.
480 instances.
So with the Jenkins, it's 1 by 1. You do first canaries. Who you manage your maintenance windows?
Yeah, good question. We have one staging server I could show, which we just manually trigger. We could do it from Jenkins, just upload, which actually just triggers the Ansible playbook, which launches a Topaz, which launches Metacello to load the code. We also have pieces of JavaScript code, so that would be Webpack and so on to bundle that. But deployments to customers is we log in and or running the playbook to upgrade a particular set of customers. Yeah, that's done manually, but scripted because we don't do 1 by 1.
You trigger manually and it has to work.
Yeah. So the
but you can choose if you have one client that it's the right time for them, but not
exactly.
Every one you can do that.
Yeah, we only have 40 servers, and the thing what we do is we would do if we roll out a major version, we would just do 1 customer per server, and then see if everything goes right. and then the next day another 1, and then that means 12 days. And we don't have automated fallback, which we should. And a backup is taken, and then if something goes wrong, we need to intervene. So for us,
when you use the J, then
no, in that case we will just use predefined scripts, bash scripts, which just we say, well, roll back this customer to the backup and then leave it like that. So we have all automated tools for that. Now the J would be more, there's a bug, I need to debug. Yeah. Then we connect to the stone and we take a look at the object log to the stack there and start debugging. Or we take the backup, put it locally and use J locally.
Yeah.
All right, thank you.
one of backend developers at OpenBus, and today we're going to see implementing a distributed project pool using Redis. So, the context. Okay, what we did, we developed a distributed object pool capable of preserving and using objects in a distributed environment. And by that, we mean across several small communities. And also keep the object collection synchronized across different instances of the pool located in different small communities. From now on, we can thought that we may have one small community per machine or several. That's model. So, what we need to solve that we need to implement this pool. At OpenBus, we did an integration with Prisma, that is a payload processor. And Prisma assigns a logical channel that is called a terminal. That quantity of terminal is fixed, and the terminal must be logged until the transaction is sent. Until the end, either the transaction succeeds or fails. Because not only there are sequential numbers that must be updated correctly, but also at the end of the day, the batch closure, that is a summary of the transaction sent by the terminal, must be correct. So, what are the challenges in distributed project logging? We have to ensure explosive access to the object, maintaining consistent state across the images, and handling failures. For example, at process level or at image level. So, what are the synchronization requirements of the tool? We have atomic object acquisition. If two processes try to log an object, only one of them must succeed. Also, we have to manage timeouts and lists because the object cannot be indefinitely logged. Also, we have to have mechanism for automatic log release for handling image failures. And also, all of this with a minimal performance overlap. Okay, here we have a model, and the important thing is the protocol of the distributed pool. We have borrow, and the pool returns any object, any key object, borrow an object, return an object, and two methods for adding and removing objects from the pool. Okay, so the title. How we solve it? Okay, we use Redis. What is Redis? It's a memory database giving you layers and can be used as a database, cache, and message broker. It has a variety of data structures. We also provide atomic operations, transactions, and publish as messaging support, precedence, and application. We consider using Memcache for this, but we decided on Redis because Redis has published messaging support. We need those two things: atomic operations and publish messaging support. This is a very high level diagram of the implementation. We have the distributed pool with the collections that must be synchronized, idle objects and borrowed objects. We have two connections to Redis, one for logging the objects, that is the messaging connection, and another one for that is synchronization connection for the events, the stream events. And also we have a show for handling objects that is the object that is unlocked at the threshold.
Well, hello, I'm Santiago, I'm backend developer, like Diego, we both work at OpenPass, and no, demo time, so I will show you this working. Well, the idea is to have a pool object in different images running at the same time. And the pool has a collection of objects that are available to borrow. And we have two times here. We have timeout, that's the time, well, first of all, this pool can borrow, can lend objects randomly, or you can ask for one in particular. Maybe sometimes, in our case, we need to use the same terminal. For example, if we need to transmit reverse of a transaction, we need to use the same terminal that we used for the original transaction. So we can borrow an object, or we can borrow an object specifically. And this time locks you, for example, if the terminal 1 is borrowed, now if you want to borrow the same terminal, you can wait until this time, until the object was released first. And we have another expiration threshold time that represents the time when the object released automatically. For example, if it is locked and this time expired, there's a mechanism that frees the terminal. So in these cases, we have the same pool in both images, and these are the 4 terminals that we have, and these are the idle objects. At this time, we have the same 4 objects, and we have another collection that's the borrowed objects. It's empty. And we can, for example, borrow one terminal, anyone. So you execute this in this image, and now we have the borrowed terminal is terminal 2 for this image. And for this image, and if I inspect the pool borrowed objects at the other image, I have the same terminal that was borrowed, and this happened through the Redis. Here we can see this is the locked mark that we use. We use Redis to keep locked the object, and sorry, I will write with the message. And to synchronize the internal collections of the pool. So these collections, the idle objects and the borrowed objects, are the same in both images. No, borrowed and idle have 3. And this happens through the Redis usage. For example, now I will borrow another from this image. I ask for another terminal. Okay, now we have terminal 3 for this, and we have Redis. Two locks, one per option. And in the message, this channel, the borrowed objects channel, indicates to the other nodes that which object was borrowed, and with that event, the pool synchronized the internal connections. When we return, for example, we return, I don't remember which, the borrowed object, I can return it. Okay. If I return this, so I return the terminal, I can't remember which terminal we have. But now I have one dot, and in the messages, you can see in the channel of returned objects, the message that indicates that object was returned. And in the other image, for example, if we inspect the borrowed object, now we have one, this one, and we can return it just from any of the images. I can return it from this or from this, it's the same. This is the terminal 3, so I can return terminal 3 from here. And in red, and red is now, I haven't got any log mark. Both collections are synchronized. I have now the 4 terminals idle in the idle collection in both images. Well, this is one of our cases. For example, here when I talk about this time, for example, I imagine that I need to use the same terminal from different images. So the one, this image, the yellow one, will borrow the terminal 1. So as the terminal 1 is borrowed, this is the log credits, and in the second one I want to get the same. Well, it is waiting. It's 10 seconds here. If the terminal is not returned in this time, it will return me. But if I return in the middle, we'll try to do it quickly. I need to try to get the terminal here, and I return it here. So now I have the terminal 1 now is forward at the other image. Well, I return it. And we have another time that is threshold, but we use it in certain cases. Not always we need to the objects be returned automatically, because here we have some transactions that depend one after the other, so we need to guarantee that the first transaction is ended for good or bad, but if it failed, it will need to be reversed and transmit to the payment processor. We need to transmit the reverse, so we can't release the terminal until that moment. So, but in other cases, yes, we after a time, if the terminal is not returned, maybe because one node
goes down.
Yes, for example, if one node goes down, the other node takes the task to release the terminal that was marked as locked in Redis. For example, here we have 30 seconds, and this is one example that I can borrow the terminal 3, for example. Okay, now I have it borrowed, and if I see Redis here, okay, this is the log. And well, after a few seconds, I hope this will disappear. And in that moment, the same, all the collections between the images will be synchronized. How much time? Okay. Yes. Now, and here we saw the message. Oh, yes, the message in the return object channel. And what else? For example, no, I don't know. That's all. Maybe that's all the cases that we use. We decided to use Redis because of these two features. We can use it as memcache, for example, with a key and a value to mark the locked objects, and we use these channels to publish and to subscribe to these channels to know when something happened in the other small because when you subscribe through a callback and you analyze each one of these notifications, and it depends on the channel that you are publishing, you add or remove the object from different collections. I don't know if someone has any question. Yes.
Have you guys finished that?
I didn't get the mechanism, but you borrow an object at the same time. So you have to get an object and move it into another collection or something. So it's a borrowed object. So what is the insurance that two borrowing actions at the same time do not return something or return the object to two images?
Because the first one that can write the key in Redis wins, and the other one is receive another response from Redis that indicates that the object is just locked before.
So then the two operations together are something similar.
Yeah. Yes, it is. Set is the atomic in Redis. So whenever the two processes try to set the variable, and in this case it will be object ID, the second one first. That's the atomic. The command set an X in Redis is atomic, and it only answer, I don't know, 1 or 0 or 0 if it does not exist before.
Sorry, creating an object is an exclusive operation, and then we rely on the first one.
Yes. Okay.
And have you guys thought or implemented great to like virtual readers, like you're sharing read only, for example, with one thing? Because when you just explain, it's like the first one that writes code, the rest deterministic, continuistic write. But have you guys found some for the use case? I don't know what the use case is, right? But that remote the object framework. Anything that is related to share reads and you have policies or how are you working with that?
Okay, let me get no, I think it's a more classical problem. So you only one personal time can use some object.
No, but I don't know, read and write and
Yes.
So if you have like 2,000 clients wanting to read the same object, it's only one. Okay.
I noticed you're using V8. Did you consider sometimes using SST? Maybe it has something about using the objects replication, anything like that. On V8 Smalltalk, you have the server's model framework. And I think I remember it has something about using the objects. Did you consider it or really not aware of it?
No.
It's kind of difficult to use, but it may also have some applications.
No, we don't see it. But not regarding that question, but something that I want to show also is, I forgot, but now I remember it. We are in time to show it. For example, we developed an API to monitor the state of the terminal. So you can see maybe in Grafana if there are terminals that are locked for more than more than this threshold time. For example, I will borrow these two objects out, and I will So I have, for example, here I know the full demo has 4 terminals, 2 are idle, 2 are borrowed, and I have 2 that overview time because it exceeds the threshold time that we set before, and that could be indicate that there's something you need to pay attention. Maybe it can be problems, communication problems with the payment processor or something about the network in general. Well, we use this, and this API consumes or use the same collections that we were looking here. For example, after time, if I return one of these or return all, one. I don't know, but I have returned 2 and 3, so 2 return. Okay, now I still have the 3 left. No, all the line. this is the indicator. Maybe our client need to put more terminals in the pool. If we see that it always exhausted the pool, it's an indicator that you need to add more terminals to it.
Another question was, can you grow the pool? Can you limit to 4 terminals, for example? Or can you have a minimum of 4 and then add more and then come back down if you're present?
No, you can add more terminals. Each one. Yes, it not depends on the limit. Is not okay. It's not in small case because a contract between the client and the payment process. They need to contract more terminals if they need to use more.
No, we didn't consider this that option because we were not aware. But because we reduced the cash settlement, something like main cash, and also we needed the Paris execution. So we finally ended up centralized.
Please use your time. Is you're using this only to pull terminals, or are you pulling anything else? Just to understand the use case of this.
No, we can pull anything else, but in this implementation we are tied to our model because, for example, we look objects by an object ID that we use, but it can be arranged. Maybe you can explicitly determine which method we want to identify the object. It's for any object.
Okay. Well,
yes. Yes.
Fue como. Por lo menos esa fue mi sensación.
Sí.
So,
Squeeze the bottom. I don't want to sit down.
This talk is called Addiction of Speed. Usually I do really boring talks about the innards of VMs, but I'm just going to talk about a little bit of personal history, which is about addiction and speed, and then I'm going to show you some code. So I think it's speed. So for those of you who don't know me, I started off in '83 with a summer job and a student project, and then my virtual machine was used as a research project, and I went to Queen Mary School in the University of London, and then from there I became a VM engineer at Tarde, in California, and became tech lead, and did the first 64-bit small talk, and then Quack, which became Teleplace, and eventually Pretend. I started the JIT extension of the Back to the Future screen VM, and then at Cadence, I did the. At Cadence, I did Sperma, which is both 32 bits and 64 bits. And then over the past sort of the 5 years from 2018 to 2022, trying to make what was Quack work, take the 64 bits and try and build a market, and failed. And recently I've been rescued, and with recently helping Queensland Labware, helping Labware go to 64 bits. So this is Queen Mary Field, and this is Richard Bornak. About that time, he had dark hair, and he's the head of the department, and he was a Koch theorem prover guy, and he loved ML. But really interesting guy in the department. Sorry, not him. That's me. Is this? Come on. No. Maybe he's trying to hit on me. I don't know. Peter was my sexual. He had a tooth that was cracked from the middle of his teeth to the corner. He smoked gauze, chain smoked gauze. He refused to use a computer. He had one wall of his office full of information on the Kennedy assassination. He invented a virtual machine the year that I was born. He defined the SCCD machine. That's Peter Landon. And we used to meet at the bar. Meet in the bar. Can you hear me if I speak like this? Yes. The same all week. So, the recording. Wonderful. Oh, well, that'll have to record like this.
Speak as loud as you do.
Yeah. So, Peter used to ask me how Smalltalk worked, and he would regurgitate it in the lambda calculus. And so I learned the lambda calculus because he was one of the inventors, with Strachey and all of that guy. So Peter was an exceptionally colourful and interesting man. It just made me think about computing, forced me to think about computing in a more general way. I loved him, he was fabulous. This is Richard now, and Richard wanted us to have cool machines, and yet he thought that you should do computing as a rewrite exercise. He was a mathematician, right? Computation was rewriting. And so I would tease him that all of the undergraduates should put their assignments under his door, and he should complete them with pen and then return them. Asking Richard has a different meaning. So he decided that we would all have these AUX Apple machines that ran this Apple Unix, these Macintosh 2s, and it came with a card game, which is better than FreeCell. It's called Sea Haven Towers, and it's crack cocaine for computing people. And the whole department got addicted to it. So the way it works is you're only allowed to move a card to the same suit. You can move the 7 of hearts to the 8 of hearts. Right? It has to be to the next one. So you build sequences. And let me explain the game this way. So here we go. This is a modern implementation. And of course, being such a young thing, I need my glasses, except I have to wear your. Usually they're on my head. Wonderful. I'll figure it out. We'll hold it there. But so you can move anything up to a space, right? And aces, and then the subsequent cards go onto the faces on either side. But the only thing that can move into an empty space is a king, right? And so here we're blocked, can't make any more moves, right? So you have infinite undo, and so the thing is fun, right? It's all about sequence and solving, and it's a little bit more difficult than free cell. But the issue is this genius scoring scheme, which is that if you don't touch a card, you can have another deal without losing a point. But if you touch a card and you don't solve it, you lose a point. So you have to look at it and figure out, can you solve it? And it's hard. And we loved it. And Richard said, I think I can build a solver in ML. I think the right thing to do is like move something down. If you can move a card down, you should move it down. Don't you think? And we all thought we didn't know. And he went away and he wrote the solver. But to use his solver, you have to type in the damn data. So Bill, who was a master student who decided he didn't want to do a PhD and instead became the manager of our IT effort and ran our email servers, he sat there on the Mac, this implementation, and wrote a program that dumped the paste buffer to text. And he would move a card and dump the paste buffer, and move a card and dump the paste buffer, until he decoded how the game was represented in the paste buffer. And he packaged it up and he called it Ask Richard. And you would run Richard's program with 2 clicks, you'd wait about 10 minutes, and it would tell you. And then you'd go on and play. And the whole department would spend hours and hours and hours and hours a day doing this. So, let's fast forward. I'm trying to do this one. Fast forward to a delightful and painful period in my life from 2018 to 2022. So this is Verten, as it's called, but it's it's the extension of Alan Kay's and Andreas Raab's and David Smith's croquet project, right? And it's a shared 3D space with you can scrape desktop applications, webcam, and so then we have Outlook, not Outlook, whatever the presentation thing is in Mac. And it was great, and I had to do all sorts of things like learn how JPEG images and MPEG images and video streams were changed and add echo cancellation. But we failed, and it was depressing. And by August of last year, I don't know if you've ever been to Lahaina in Maui, but Hawaii is a very, very beautiful place with very, very calm and generous people, and I love it. And it was destroyed. And if you look at this picture, you may ask yourself some questions, and that's all I'll say about it. So I was, in November, so depressed that I found this game on the web. And I started playing it. And I found that it was a piece of shit. It was like, occasionally you would tap a card twice and it would move one card down, and there was a ghost card, and then undo didn't work. And sometimes the solver here, you see that there's a hint there. And if you ask that, it will tell you what to move. So that's actually a searcher looking for a solution that can tell you what to do. Right? that would take more than a day or more than overnight, I mean, many hours. And I thought, you know, Richard could do it, I bet I could do it. And so I started, and I made the same mistake as Richard. I typed in the data. I would sit there, and you know, the first extension was an error checker. The data, I never typed it right. There were always 3 queens of spades or something. It was agony. But then the many delightful hours of profiling and trying to figure it out goes. So let's go back to this game and think about the strategy. The obvious thing that we need to do is we need to do a search, right? And a depth-first search is not going to work, right? Because you're going to go off down some rabbit hole, and it's going to take forever. So if you're going to do a breadth-first search, the challenge is there are moves which will get you into a cycle, right? You can move any card up to a space, and you can immediately move back. So you have to avoid going where you've gone before. Right? So the obvious thing to do was to try and record the state of the game so that I could keep it in a canonical representation and know that I'd seen another state before. So if you think about it, if kings can go up to the columns, then if you make 2 columns free, you could put a king in either column, right? So you need to sort the columns and maintain the columns sorted on the top card. And if you do that, it doesn't matter how you get to any state, every state is represented in exactly the same way, right? Because the first card is sorted. Right? So that was the first thing to do, was to figure out how to represent the state and how to keep it sorted. And then I could produce a hash function and just use a dictionary of previous states and keep the thing working. So if I inspect this guy, the first thing to think of was... Yes, I can. Yeah, let me do that. References. Scale, is it? Graphics. What is this thing? Is it magnification? Here we go. No. Can't remember what it's called, but it's a factor. No, that's the wrong scale factor, because I set it to 2.5. I know it's already 2.5, so that's not the right one. Font size, no? Windows, visuals, or something like that. Yeah. Alright. I don't believe this, but anyway, we'll try 2.5 and see what happens. Oh, okay, you were right. I'm sorry. I apologize. This is great. So let's take it down to like. Oh no, it's because I scaled it to 2.5 when it hadn't connected to the overhead projector. Now I understand what's going on. Okay, so let's try 1.5. Right. There we go. Is that okay? Do you think?
Still small.
Okay. 1.75. Hang on. Let's get there. Scale factor. 1.75. Squeak interface looks so great, doesn't it? Okay, there you go. Is that all right?
Yeah.
Okay. So I think I have my inspector. Here we go. So the first thing was to figure out, okay, how to represent it even before I could take a hash function. And I realized that the byte is not the ideal thing, right? So a single byte, if I use 0 as null, and I arrange that each suit is a subset of 16 values, then each suit's ace is going to start on 1, 17, 33, etc. And the king is going to be 13 further. So there's like, this kind of thing, right? Subtract 1, take modulo 16, and it's 12, etc. And then so divided by 16 gives you a suit index. So now I can use byte arrays, and the virtual machine copies byte arrays very quickly, so I can copy a game state quickly. Right? So where am I in this? So what we're doing is we're trying to produce a hash so that we can compare these things. It turns out that this thing went through some interesting evolution. And so you can imagine that the right way to do it is you have an initial state, and you have a dictionary of states, and you have a legal move generator that generates all of the moves from where we are and adds them to the pool, and then goes through the pool with all of the new states and does the legal moves for them, and any that are already in the pool get truncated. It turns out that when you push all of that through and you've found a solution, how do you print the damn thing? What you need is you need a predecessor link. Each state needs to know the state it came from, so that when you find the solution, you can actually print out the solution, which is what you want to do. You want to win the damn game, right? So I, worked on solving it, and then I couldn't print the data, so that was silly. So when you do that, and you have a predecessor link, then you don't need the hash at all. All you need to do is arrange that you're not going back to a state that you've already come from. And if you go to the same state somewhere else in your search, and you get to exactly the same point, it doesn't matter, because you're doing this breadth-first search. And in breadth-first search, you will always get to the nearest solution first. Right? So you'll never waste any time looking at this thing twice, because if it's on the right way, okay, these things go parallel. Right? It turns out that then, instead of maintaining this huge dictionary which balloons to thousands of states and you're spending all of your time looking at it, you save so much time just looking back at your predecessors that you can throw that away and not use the hash. So that was kind of interesting. And so let me show you what the legal move generator looks like. So, oh no, let's not do that yet. All right. First of all, we have to see, can we beat this thing? So, okay. Back to my slides. This is a comparison of this third generation iPhone SE against this first generation Apple Silicon M1. And there's a bit of difference, right? The M1 is a little bit faster, but this thing is essentially unity. It's essentially the same speed. It's like 86% to 90% depending on the benchmark. So we can actually think of these two things as the same, which is astounding. I thought that this would be like 5 times slower or something, but no, it's not true. So what I want somebody to do in the audience is look at their watch, and what I'm going to do is I'm going to say restart, and when I say restart, it is going to go dark, it's going to go grey, and it will go white when it's figured out the next move. When it's done a complete search and it knows the next move, okay? So you have the time for me. And so that, that's what we're talking about. So restart. And now it's gone, so you're timing it, right? And I've not been able to play this since like last week. Because I've had to keep this one So I can demo it for the talk. It's been agony. I'm like, the first thing I'm going to do when I finish is like play another game, is I'm going to finish this. So how long did that take?
A little over 16 seconds.
16 seconds. I'll take 16 seconds. So okay. So I, there am I, like a buffoon, like Richard, typing in the data, and I'm finding bugs, and I think, okay, let's go into help, and it's got report game. And let's complain to the developers and say, look, I've got a better solver than you. But look, there's the game state. But that one's no good, because if there's a column which only has 4 cards in, right, then that last row is all shuffled along, and it's no longer in the line. There's no space. So I wrote an importer from that, and then realized that that was done, that wasn't going to work. And further down is, of course, the lovely XML. So select XML, and the ghost of Steve Jobs comes to your rescue. And say copy, and then say. So what I've got here is from clipboard, which imports the XML, and then breadth first solution. So this captures the solution, and then what we're doing is forming an array with the time to run, and then we ask that to print the moves. So we're going to get both the solution. So there it is. Copy the data, and it takes 3.5 seconds. So I don't know what this is made of. Objective-C, C++, whatever. But whatever it is, it's so bad that they can't write us a correct solver. And if you do the small talk right, you can beat them hands down. So now we can have a look at kind of what the thing does now. And I won't belabor the point, but I'll give you a small one. So the API is find a breadth first solution, which depends on all legal moves breadth first do, or breadth first solutions, in which case you collect them, or you can decide that you're going to look to a particular depth. So this is the one that we're using, and all legal moves breadth first do is let me drag this onto the straight away. It's the most incomprehensible small talk you've ever seen, because to save time evaluating doing an instance creation of a block in a loop for each state, I allocate the block once at the start. So I'm doing strength reduction by hand, right? To say, because when you copy one of these states, you've got an array of the 10 columns. So you're copying the array and each of the 10 columns, so and then the object itself, and then the 2 arrays for the spaces and the bases. So a closure in there is noticeable. It's going to be like 5% of your allocations, right? So you want to avoid that. So you can't make sense of this algorithm anymore, because you have to like mentally put things in. So what it's doing is it's grabbing a current state from all of the states that we've generated from the last boundary, right? So we start off with one state and we create some number of states of all of the legal moves, and then we move forward from there. And so we're moving forward this frontier of states, and we want to ask each state, are you stuck? So there's a thing that happens, because you've only got 4 spaces. As soon as you get 6 cards in a line on top in a column, and there's one of the same suit lower than it, it's stuck. Because you can't move these 6 cards. You need 4 spaces to get rid of 4 of them, and then move one somewhere else. Right? So you can move n plus 1 cards. So you can figure out if a state is not worth pursuing, and that's important, dropping the search tree. And then we want to find out if it's new, because it's only worth following if it's new. And so new used to be, if novel used to be this really complicated, let's hash and look in a dictionary of states and having all of that memory. But now it's much simpler. It's just, let's go and have a look at our predecessor and ask it, has it seen it before? And so it's just, and these things are like 35, 20, 40 moves deep, right? So they're very, very quick. So that's very simple. And so if it's not stuck and it's novel and it's solved, then you evaluate the block, but you add it to the set of states, the next states that you're going to explore. And so the loop is just through the current states, apply the outer evaluator and the inner evaluator, and then replace the current states with the next states that you've got. And the only other thing to give you is like one example of a legal move. So, for example, this is the method that is where's this set from? This is set from. So here's the legal move generator with some piece of debugging in it that I don't need. And so you just enumerate over all of the possible moves from the spaces, and all of the possible moves from stacks, stacks to stacks, stacks to spaces, and then consider moving any top card of a stack up to the space. And so those are the three, and they all look more or less like this. They're very straightforward. So this one goes through the spaces, and if the card that you find in the space is a king, that can only go down into an empty space. So you search for a nil in the array of stacks. The card that it's going to go onto, which is one higher than it, and you search through the stacks for a stack that ends with that value. And if it does, then you create a copy of yourself where you have moved that card to that space, right? And evaluate the block with it, and that's it. So it was really nice to find that you could express it clearly enough that you could obviously get it correct, right? Because the guys who did it in the iPhone app did not manage to get it correct. Right? Probably because they had something that was taking 8 hours to solve difficult things rather than a few minutes. Anyway, that's it. And questions on any topic whatsoever?
Are you going to play right now? Are you going to continue the game right now?
Yes, let's play it. Let's play it. Why not?
Yeah, because you told us that solved it.
But I didn't show that we actually solved it. So.
I mean, I don't know. We have to trust that it actually worked.
Well, but the problem is that I'm going to have to switch between the two. So can I? What can I do? First of all, let me go through this process again. Maybe I could text the solution to somebody, and they could read out the instructions. Because otherwise, I have to look at two screens at the same time, and I can't see what I'm doing.
I'm starting to see the value of just taking your order. I'm starting to see the value of just taking your order.
No. We're going to do this. We're going to do this. We're going to get it to work. All right, there we go. All right. So. John, you ready?
John is not here.
He hasn't stepped out.
Yeah.
What's your text?
Mine? I don't know if I. What do you want to do?
Still more or less.
And your plate is green, you shall sign your forehead.
Yes, there. So we can do both at the same time, right? Because I've got instructions here. And you know, those of you who download this, you are damning yourself. So what do we start with? We go the 8 of spades to the 9, and then 10 of spades goes to the jack of spades, and then the 10 of diamonds goes up. So now the queen of clubs goes up, and the queen of diamonds goes. So somebody has to remember where I am. So I think I'm at move. I've move 5, right? So there we go. So move 5, and we get the ace goes, and it prints it out, right? The ace went, the ace closed. And so now we've got the jack of diamonds, don't jack. No, see, you can do, see, I got it wrong. Jack of diamonds goes to the queen of spades, that's right. And then 7 of spades goes to the 8. That's it, it's the 10 that goes. So now we have to do the 4 of diamonds moves to a space. So 6 comes here, and 4 of diamonds goes there. See, it's not obvious, right? Would you have figured out that that was the initial way to go?
No.
No.
But I think we understand the idea.
All right.
Thank you.
I did.
Don't go. So now we have a little. Mariano is going to. I just wanted to make it close. Okay. First of all, I want to thank the team that doesn't work. Well,
also, thank you for an interesting
week. Well, first of all, I want to thank you all for coming. Every year there's a new conference where we have fun. This is only happened because of you, because of the sponsors that we have, and because of Smalltalk and the great people that come here and talk. So first of all, thank you all. I want to thank the idea, the Universidad Nacional de Plata. It was a long-term dream we had a long time ago with Francisco, and when I got an email this year saying, "Hey, Francisco, why don't we do it? Why don't we do it this time?" And he said, "Yeah, let's go for it." So thank you, Francisco. Thank you very much. Do you want to say something? Please, come on.
I'm so happy that you are here and you have enjoyed this event and have a good time.
Great. Again, thank you all for everything I say. Okay, I remember. And the two most important people that made this possible, besides Francisco, Mariano, and Maxi, they did their work, they do their work. We can believe me, I only have the signature, paychecks.
President.
I'm the president. President. So, thank you very much. We'll see you next year. Yeah.
Gabi, also help us.
Oh, yeah, Gabriela.
No, Gabi.
Yes. Oh, yes, Gabi.
Gabi also help us. So.
Yeah. I'm sure other people do, but I just want to say the most important at least to me. And next year we'll see you at. We don't know. We don't know. See you next year. Bye.